Hello everyone, my name is Ikechukwu Anyam with Holt Integrated Circuits. In this video, we're going to introduce the Holt Portable Library, next generation software architecture for military standard 1553 development. At Holt Integrated Circuits, our mission is to deliver high reliability IC solutions and outstanding support for aerospace and defense systems. Our products are trusted worldwide in mission critical applications, from flight control to weapon systems, helping customers reduce risk, simplify design, and support programs for the long term. Traditional MIL-STD 1553 integration forces engineers to wrestle with raw silicon, and it shows up as four bottlenecks. Tight hardware coupling locks software to a specific chip. Synchronous ISR latency stalls the CPU on every SPI transaction. Manual buffer parsing burns cycles decoding raw 5053 frames word by word. And a 32-entry hardware log forces aggressive polling just to avoid losing events. The result? Brittle, latency-sensitive code that's expensive to maintain. And exactly what we're about to solve. The HPL shifts the focus from manual custom development to a more automated and reusable approach. Instead of building interface functionality from scratch each time, you can leverage a portable library that standardizes configuration and enables automated deployment across platforms. The result is less manual effort, faster integration, and a more scalable path to supporting multiple programs. The HPL stacks 4 layers between your application and the silicon: a standardized upper service API, a management layer for config and topology, an OS abstraction layer that adapts to your RTOS, and a lower service provider that handles the bus: SPI, EBI, or PCIe. Your code stays the same across Mamba, HI6130, HI2130, and HI62XX. The OSOL is what lets the HPL run anywhere: Linux, and RTOS, or bare metal. It abstracts the 4 things every OS handles differently: memory allocation, thread synchronization, time and delay, and logging. Point it at your environment's primitives, and the same HPL code drops in cleanly. Device bring up follows a strict 5-step block. First, Holt API config declares your environment. Then, Holt API init arms the global state. Holt API dev map registers topology and buses. Holt API dev open hands back the channel handle, and only then can you enter the device control regime for live operation. Synchronous SPI reads inside the ISR cause deadlocks and latency that didn't scale. The HPL moves these reads into a deferred work queue, so the ISR exits immediately and the work runs safely outside interrupt context, eliminating deadlocks and unlocking scalability. Terminal data arrives in all kinds of shapes. Comprehensive mode marshals every message through Holt mode comp into one predictable structure, so downstream code consumes a single, consistent abstraction. In basic compatibility mode, raw and decoded messages have different footprints, so every decode forces a separate allocation and a memory copy. Comprehensive mode keeps the footprints matched, letting us transform raw data into decoded structures in place. Same memory, zero copy. The result is real CPU cycles handled back to your application logic. 32-entry logs drop data under load. The HPL converts it into a large circular stack, eliminating overflows and reducing host polling. The Mamba platform is our ready-to-deploy reference for modern SoCs. It pairs the Holt board with an ARM Cortex host and ships with pre-configured BSPs for STM32Cube IDE. The 4-wire SPI host interface maps cleanly through the HPL OSOL, and the integration demonstrates concurrent RT, BC, and MT operations working side by side, proving the full stack on real hardware, not just in simulation. This is the ROI of abstraction. The HPL accelerates time to deployment by removing manual parsing and giving you a pre-configured OSOL across every supported MCU. It scales: one thread safe architecture, concurrent multi-device support, and clean fan-out across topologies. And it raises the reliability bar. Deferred interrupts prevent deadlocks, BC, RT, and MT all stay safely isolated, and the 32-entry log overflow problem is gone. In summary, the Holt Portable Library separates hardware dependencies from core logic, enabling faster development, easier integration, and scalable deployment across platforms. It provides a solid foundation for building reliable, high-performance solutions. For additional support and services, please visit holtic.com. There you can find our vast portfolio of military standard 1553, ARINC 429, and discrete digital devices, as well as many other solutions. Visit our website, explore our development tools, or reach out to our applications team to see how Holt can support your program. from architecture through long-term production. Thanks for watching.